Here's another way of practicing the bounds, or setting up the bounds for iterated integrals. And that's called reversing the order of integration. So for example, let's say that we have this iterated integral. I'm not going to tell you what the integrand is. But the integral from 0 to 4, integral from square root of y to 2 of the function f d something. First of all, can you look at that and tell which order this is, dx dy or dy dx? Hopefully you're seeing that since this would be from x equals square root of y to x equals 2, the inside bound must be x and the outside bound y. So what I want us to do with this is first of all draw the region and then reverse the order of integration. So let's start off with the two curves, x equals square root of y and x equals 2. X equals square root of y is going to be at least part of y equals x squared, just the right-hand part of it. So x equals square root of y looks like that. X equals 2 is a vertical line. So x equals 2 looks like this. Notice if you want to figure out where they cross, we can set them equal to each other. So square root of y equals 2, so y is 4. So they're going to cross here at a point with the y coordinate of 4, and the x coordinate is 2. Now on the outside, y is going to stay between 0 and 4, which means that I'm starting off down here at 0 and stopping up where this y coordinate is 4. Now since I'm in the order dx dy, that means that I'm slicing horizontally. And notice that I'm starting on the square root of y. So I'm starting on the square root curve. And I'm exiting, or leaving, on x equals 2. So notice I'm entering on x equals square root of y, and I'm exiting on x equals 2. So if I do that all the way from y equals 0 up to y equals 4, that's the region I have. So that's drawing R. We've done that. Now let's see if we can reverse the order of integration. So let's draw the picture again. Same region. But this time, I want to slice it vertically. Well, notice now I'm entering on the x-axis, which is the same as y equals 0. And I'm exiting on the parabola, but I'd like to write the parabola in the form y equals something. Well, if x is the square root of y, then y equals x squared. So, in this order, the inside variable is going to be y. I'm going to start at y equals 0 and stop at y equals x squared. My outside variable is x. Notice that the smallest value of x in the region is x equals 0, and the largest value of x in the region is x equals 2. So that's going to be what the integral looks like after we've reversed the order of integration. We've reversed it from dx dy to dy dx.